Here in example 1, we're going to match each exponential function, g of x, r of x, n of x, and k of x, to its graph. To start this process, I really like to take a moment and just find where all of our y-intercepts are located, and also any clean points, particularly what happens when x is equal to 1. Because those are the points that I encouraged you in the introduction to look at on a table. So we see here in all 4 of these graph options that the y-intercept of each of our graphs is equal to 1. We also see the varying values of what's happening when x is equal to 1. So in our first graph, when x is 1, y is 3. On our second graph, where x is 1, y is 4. On our third graph, where x is 1, y is 2. In our fourth graph, where x is 1, y is 5. So I'm hoping that you're going to quickly begin to see a pattern of behavior given the functions that we have to work with. Our first function to look at is g of x is equal to 2 to the x power. So to get this started, let's look at a. A is the part of our equation that does not have an exponent on it that comes at the very beginning. And we learned in the introduction that if there is no number here in front of the equation that doesn't have an exponent on it, then we know that a is equal to 1. And you have learned from all of your mathematical training that if there is no symbol showing, then we also know that a is equal to a positive 1. So from the introduction, we saw that if a is a positive number, then our graph is going to be moving steeply upward to the right, or possibly just flattening out as we move to the right. So let's look at what b is. b is equal to 2, and b is always the number that has the exponent on it. So here we're looking with b if it is greater than or less than 1. So 2 is obviously greater than 1. And curves with a b that are greater than 1 move to the right either sharply upward or sharply downward. So from this, right now, we can already begin to see what the shape of the graph should be. So we say, what do these two sets of options A and B have in common? Oh, they have this one, this moving sharply upward to the right, which makes sense because all 4 of these graph options have the same style of graph, moving sharply upward as we travel to the right. Now let's talk about C. So C comes at the end of our exponential function, and we said in the introduction, if there is no number added or subtracted at the end, then C is equal to 0. So this is where our horizontal asymptote would be if we were asked to graph it. So we continue this process by now adding a plus c. So my a value was a positive 1. My c value is 0. Why do we do this? Because we saw in the introduction that a plus c is the y-intercept, which 1 plus 0 is 1. Great. So now let's finish this off by looking at, do we have any options? Well, before we do that, let's make our tiny table. So our tiny table of x and y values, really I need the x is equal to 0 and then x is equal to 1. So our y-intercept happens when x is equal to 0, and we saw the y-intercept is 1. And all 4 of these graphs have a y-intercept of 1. So that still stands, but it hasn't really helped narrow things down for us. So let's find out what happens when x is equal to 1 by plugging this 1 into our original equation for the x value. So 2 to the 1 power is just 1, 2, which you can either get by knowing or you can get by putting it into a calculator. So here's where things get to be narrowed down nicely. This coordinate point is currently living at an address of 1, 3. Here we have a coordinate point at 1, 4. Here's a coordinate point at 1, 2. And finally, a coordinate point at 1, 5. So now we know what the height is, what the coordinate point is whenever x is equal to 1. And there it is. There's the one that we need. It's right down here at the bottom. And so we can say that this bottom graph is our g of x, which equals 2 to the x power. Let's analyze our second equation that we need to process. So r of x equals 3 to the x power, again, starting with a. So again, if there is no number showing here in front of the number that has an exponent, then we know that a is a 1. And from your previous math learnings, if there's no symbol here, it is a positive 1. And we learned in the introduction that graphs with a positive a value will travel steeply upward to the right, or they're going to kind of bottom out, flatten out as we travel to the right. Our b in this equation is a 3, and 3 is most definitely greater than 1. So again, from the introduction, we know that when b is greater than 1, our graph is going to travel steeply upward to the right, or it's going to travel steeply downward to the right. And just like we did with our previous equation that we analyzed, we say, all right, so a and b have what style of curve in common? Here it is, steeply upward to the right. And that still matches all of the graphing options that we have. So good deal. Let's go look at C. So as we said with our first equation, that if there is no number showing adding or subtracting at the end of our equation, then we know that that is a 0. So our C value is 0, and if we were asked for the horizontal asymptote of our graph, we could say C is equal to 0. We use that to find our intercept, our y-intercept, by adding a plus c. So we have 1 plus 0. So again, our y-intercept is equal to 1, which stands to be true for all 4 of our graphing options. So let's finish this off, because we haven't been able to narrow down our search, by making a tiny little table where we've got x values of 0 and 1. So the y-intercept is when x is 0, so that has a value of 1. And then let's plug a 1 in for the x value of our equation. So 3 to the first power is just a 3. And we look at our 4 graphing options and we say, oh yeah, here we are. Here's the only graph that has a coordinate point on its curve of 1, 3 that we saw here in our little table. So that gives me an equation of an exponential function of 3 to the x power. For the purpose of being able to see the writing of analyzing graphs, we're going to analyze in a slightly out of order fashion. So let's look at k of x is equal to 5 to the x power. So again, let's start off with a. So a still is sitting here in front of the 5 as an invisible, understood, assumed positive 1. And we know that that means our curve is going to travel steeply upward to the right, or it's going to flatten out, bottom out as we travel to the right. And b is equal to 5, because it is our number that is a base that has an exponent of x. And 5 is most definitely greater than 1. So its curve travels either steeply upward to the right or steeply downward to the right. And as we've seen before, what a and b have in common is this traveling to the right steeply upward. Okay, so let's continue forward looking for c. So c, still the number at the end of our equation. And again, if nothing is visible there, that means c is equal to 0. And we use that to help us with a horizontal asymptote. Or, well, actually, in addition, we can use it to help us find our y-intercept. So a is 1, and c is 0, which means that our y-intercept is their sum, which is going to be 1. And from there, we can make our little t-chart to help us plot important points. We know that we can graph the y-intercept, which is x is 0, out 1. And then we can figure out, by plugging in 1 for the x value, that 5 to the first power is just 5. So here it is, the graph that shows us a coordinate point of 1, 5. That means that our bottom right graph option has an equation of k of x is equal to 5 to the x power. So reasoning says that the equation we haven't used yet should be the graph that we haven't labeled yet. But we're going to verify that we've actually done the work correctly. So let's do that. So n of x is equal to 4 to the x power. Again, a is equal to a positive 1 because there's no number here in front of our base that does have an exponent. So again, we know that our graph either has to travel steeply upward to the right, or it has to flatten out, bottom out as we travel to the right. And b is equal to 4 because b is for base, you could say that. And it has an exponent, which is definitely greater than 1. So our graph is going to travel steeply upward to the right or steeply downward to the right. And again, we say what A and B have in common. That same one. So good. That agrees with the graph that we have still available as an answer option. We look at C. In C, because it is not showing in our equation, we know is equal to 0. And we can use that to help us find our y-intercept. Since A is 1 and C is 0, that means that our y-intercept is equal to 1. And finally, let's go make our little table of x and y values. So we know our y-intercept when x is 0 is equal to 1. And let's plug in this 1 into our equation for x. And we get 4 to the first power is equal to 4. And don't you know it? That is exactly what we find in the one graph answer option that we haven't used yet, which is really great to know that we don't have to depend on just the answer we haven't used yet, because we know that we've done it right. And there you go.